But okay, we are 5.3a. We're graphing square root functions. The graphs of square roots will always be in this shape. Always. Okay. And this right here is my parent function. 0, 0, 1, 1, 4, 2, 9, 3. So today we're going to talk about how could I make a shift to this? Because if my graph always looks like this hook kind of thing, if I shifted it like 2 to the right and 3 up, where would my starting point be? Or if I went 4 to the left and 4 down, right? Where would my starting point be? So this shape is what you'll always see for a square root function. So here again, we're just talking about the basics. Here's the shape of it. The end point is 0, 0. The end point is also my HK. I call that sometimes my initial starting point. There's lots of different ways to say it. Initial starting point. The domain for this, the better way to write domain is going to be a bracket 0, infinity with the parentheses. And then my range for this parent function would be 0, infinity as well. Because look at it. Along domain, nothing negative, nothing negative, nothing negative. Oh, 0, it hits. And then 1, 2, 3, 4, 5, 6, 7 to the right. Infinity, all the way. Range starts low. Nothing negative, nothing negative, nothing negative. Up 0, 1, 2, 3, 4, 5. And you realize this arrow is just going to get higher and higher and higher and higher. So it'll go towards positive infinity on the range. H is my horizontal shift. The positive shifts left. The negative shifts right. We know that from previous transformations. My K is my vertical shift. The positive shifts up, the negative shifts down. Okay. My end point or turning point is going to be my HK. Initial starting point, we also call it. If A is negative, that means that I would have a negative A, negative square root of X would look like this. It would be reflected across the x-axis. Reflected across the x-axis. If A is a whole number and positive, a whole number, like a 2, 3, 4, 5, it's called a vertical stretch. If A is a fraction between 0 and 1, it's a vertical compression. Okay. All right. Now let's describe what happens when we actually put this into practice with an H and a K. All right. So 7 what and 2 what? Someone tell me. 7 what and 2 what? No one? Okay, well, the sign is opposite. So 7 to the right, 2 up. Okay, let's get our brains, the transformations. It's been a while since we've done them, but 1/2 means that I have a vertical compression by 1/2. Now tell me what the 2 means and the 6 means. 2 what, 6 what?
2 to the left and 6 down.
2 left, 6 down.
Yes, you're both right. Perfect. Number 3, the square root parent function is reflected across the x-axis. That means I have a negative like a or like -1 or something. Then shifted 7 left and 1 down. 7 left and 1 down. F of x equals 7 left and 1 down. So it's a negative square root. 7 left, x plus 7, 1 down, -1. My starting point or end point would be -7, -1. Whoa, well, there's a bummer. Okay. -7, -1. On the left here, the values of h and k can be written as a coordinate point. That will be the starting point or end point, starting or the end points of the graph. And this point defines the amount of translation. Wherever your endpoint is located, that's where it's translated. Like this one was going to be 7 to the left and 1 down. Let's put this into practice and do some graphing. Okay, so turn the page. 4, 5, and 6. I have a little typo I need to fix, please. For a square root function, the x values cannot be negative. We have no negative square roots. So the domain of the parent function is bracket 0, infinity. The range is bracket 0, infinity. So you need to remember what my parent function is. Parent function. Because I'm going to use this parent function to make my shifts. 0, 0, 1, 1, 4, 2, 9, 3, right? I'm going to draw the parent function for 4, 5, and 6. 0, 0, 1, 1, 4, 1, 2, 3, 4, and 2, 9, 3. Okay. That's my parent function. Now let's do this one in green. This just means 5 up. I'm literally going to go ordered pair by ordered pair. I am not going to plug in a new table of values. I'm going to make this easy on myself. I'm going to take this graph right here in pencil, and I'm going to shift the whole thing 5 up. Every dot, just move 5 up. 1, 2, 3, 4, 5, make a dot. 1, 1, go 5 up. 1, 2, 3, 4, 5, make a dot. 4, 2, go 5 up. 1, 2, 3, 4, 5. 9, 3, 1, 2, 3, 4, 5. Perfect. And that's what my new transformed graph looks like. Since I shifted it up 5, my range is going to change. Range is going to change. My domain is going to stay 0, infinity. Because look, it starts at 0 and it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, blah, 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 blah. My range though, 5, infinity. Because look, nothing, 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 nothing. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, up, 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 up. My turning point and my end point is my HK, remember? 0, 5. end behavior. Like, what is the arrow doing? Well, as my x goes to the right towards infinity, my y value is going up towards positive infinity. And I always put my end point, my turning point, as the other end behavior. So 0, 5. As x approaches 0, y is getting closer to 5 because y is at 5, right? When x is at 0, y is at 5. 0, 5. An increasing interval means, where does my graph go upward? Well, guess what? It goes upward at 0, infinity, right here. Along the x-axis at 0 and then upwards. It never decreases. So just to like draw a line. Nope, it's not decreasing at all.
Miss Grant.
Yeah,
Why did you put a bracket at the beginning?
because it's a closed circle. 0 is at. It's a closed circle. And it's included. So that's what bracket means. Number 5. Okay, what's happening with the 1 and the 4? 1 what? 4 what?
1 to the right and 4 down.
One to the right and 4 down. Perfect. Let me graph my parent function. Okay, this is my parent function. I'm going to do my new graph in green. 1 to the right and 4 up. Every single ordered pair. Move it. 1 to the right and 4 up. So here's my 0, 0. Go 1 to the right and 4 up. 1, 1. 1 to the right, 4 up. 4, 2. 1 to the right, 4 up. 9, 3. 1 to the right, 4 up.
Wait, isn't it 4 down?
Oh no, it is. Meh. Oh my. Good call. 4 down. 1 to the right, 4 down. Bummer. The smallest mistake. Look what happened. 4 down. Huh. Thanks for pointing that out. My endpoint just switched to 1, -4. I could wipe those out, I think. It's like they were never there. There's just a giant white streak. All right. My domain changed. I went 1 to the right. That means that my domain is now at 1, infinity, no longer at 0. My range is at -4. -4, infinity. Okay. So look at how down it went. So I have in my range starts at -4, but then it goes -3, -2, -1, 0, 1, 2, 3. It goes up, up, up. End behavior. As x goes to the right towards infinity, y goes up towards infinity. Oh, and then my endpoint is the other end behavior, always. 1, -4. Increasing interval at 1 in infinity. That's where it starts going upward. The green starts going upward. There is no decreasing at all. Okay. Number 6. Oh, there is a negative leading the way. So there's like a -1 for A. 2 to the right, 3 up. Let me draw the parent function for you in pencil. If it's a negative, it goes downward like this. Okay. That's what the parent function looks like. Now my green is going to go downward like that. It's going to have that downward shape, but it's going to be 2 to the right and 3 up. So every ordered pair, translate 2 to the right, 3 up. 2 to the right, 3 up. Every single ordered pair, 2 to the right, 3 up. 2 to the right, 3 up. 2 to the right, 3 up. My end point is at 2, 3. This also affects my domain and range, especially the range if it goes downward. The range is affected because it's going downward. My range is now beginning at negative infinity and it tops out, oh, whoa, parentheses, negative infinity. And it bracket at 3. Okay, my domain is bracket 2, infinity.
Miss Grant, for the range, why wouldn't it be the other way around, like 3, negative infinity?
I'll tell you. So I have my range. Isn't this green line going to slowly get lower and lower and lower and lower? So this green line is going to eventually be negative, negative, everything. So it would be where my ruler is now. Yes, 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 yes. Negative infinity, negative infinity. The range stops at 3. Like this top point, 3. It stops at 3.
Oh, so in this case, it's the end point, not the starting point.
It's the same. No, this is still the starting point. It just goes downward. The end point and starting point are the same word.
Okay.
Where the graph doesn't have the arrow, where it's just the solid dot. It's just because it's going downward, my range changed. As x approaches infinity, y approaches downward, negative infinity. See that? As x goes to the right, y goes down. And as x, here's my endpoint, 2, 3. That's always like my second end behavior. Because when x is at 2, where's y? When x is at 2, where's y? It's at 3. This graph does not increase at all, but it sure does go down, 2, infinity. I'm going to let you guys get caught up. Let me press pause for a second. All right, we're going on to the next page. So now I'm going to give you a picture of a graph and I'm going to say what happened. So you have your f of x is here. Your g of x is green right here. There's a negative here that should not be here. You need to cross out this negative. That's a typo. Okay. Someone tell me, what does the 1/2 do? What does the 1 do? What does the 3 do? What happened in my graphs? And we're just going to write those down. What transformation of f of x produced g of x? What is it? What did the 1/2 do? Look at page 1. What does a 1/2 do when I have a fraction for a? What does the 1 do? What does the 3 do?
The 1/2 makes it more compressed.
So I'm going to say the 1/2 is a compression. Yep. You can see how the shape changes, what that compression looks like, right? So, okay, keep going, or anyone. What does the 1 do? What does the 3 do?
The 1 shifts it to the right and the -3 shifts it down.
3 down. Good job. And then it says, what effect does the transformation have on the domain and range of g of x? Well, on the domain, it means I just went horizontally 1 unit. On the range, it just means I went vertical down 3. So I looked at a graph and I said, what happened, right? Use the properties of radicals to rewrite the function and identify the vertical change or shifts. Rewriting. See how 9 is a perfect square? Yeah. Square root of 9x, guys. What happens to the 9? Right? 3 radical x. My a is now 3. That's a stretch. So it's a perfect square for a reason. It's a 9, like not by accident, because that's a perfect square. So real quick, here's my F, and here's G. That's what the 3 does to it. The next one, here's F, and here's H. So 4x plus 16. Underneath the square root is what I need to simplify. I want to take a perfect square out of it. I'm not going to worry about the 7 till like really at all. So 4x plus 16 has the GCF. It's 4. X plus 4 plus 7. Four is the perfect square. It comes out. 2 radical x plus 4 plus 7. Yay. This is good. That means, dun, 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 2 is my A, and then I have 4 to the left, 7 up. 4 to the left and 7 up. Your homework is the next pages, 1 through 6. And that will be posted in 5.3a of your digital notebook, which is the candy cane. The candy cane digital notebook. You got to go back to that one, okay? Let me stop the recording.